Do you see my screen?
Yes,
Yes,
sir.
sir.
Okay.
Yes,
Sir.
sir.
Yes, sir.
So for tonight's special meeting, special virtual meeting, we look at into experimental, the quasi or the quasi-experimental and the ex post facto designs. So when I say experimental, that refers to the different experimental designs. We have true experimental designs and other designs for true experimental. Then we go to quasi or quasi-experimental and then the ex post facto designs. So these are the things that we're going to take up for this special meeting. So we look at into cause and effect. When we talk about experimental designs, we look at about cause and effect. We often want to know what leads to what kind of effect. If we know some effect, then we are going to ask what are the causes of the effects. That is to identify cause and effect, maybe in terms of relationships. But I mentioned earlier in our class that when we talk about correlation, it does not talk about cause and effect. Although correlation is talking about relationship, but it does not actually tell cause and effect. So we look at into experimental studies. The most convincing way to achieve that is to use an experimental design. When we look at effects within our workplace, what we see in the community in terms of effect, we look at some possible causes. And if that would be the perspective of the researcher, cause and effect, then we look at experimental designs. In such a design, a researcher considers many possible factors that might cause or influence a particular condition or a phenomenon. You see a condition, you're able to observe a condition, you're able to see a phenomenon, you're able to observe a phenomenon. Then, next to your mind is about asking, what are the causes of these conditions? What are the causes of this phenomenon? The researcher attempts to control for all influential factors, except those whose possible effects are the focus of investigation. So we look at factors or the independent variables. So factors in experimental designs can be called also as independent variables. Those whose possible effects are the focus of the investigation. So an example to clarify everything what I mentioned in the previous document. We want to measure the performance of a newly invented algorithm A over an existing algorithm B. So we have algorithm A and algorithm B. And the claim of the researcher is A over an existing algorithm B. So to do so, we must discard all the possible external factors that might impact the performance. So we have difference in problem set and size. So that could be a factor on why algorithm A is better than B or B is better than algorithm A. Difference in operating system, difference in underlying hardware capacity, then many other factors that you can think on why A over an existing algorithm B. You might claim that one invention is better than the old one, or maybe another kind of teaching strategy, another kind of assessment strategy in which that is actually being claimed as better than the existing teaching strategy or than the existing assessment strategy. So to do that, we do an experimental design. However, we look at into other external factors that might impact the performance. So another example, that is we need to ensure both the algorithm was tested in equivalent environment and against the same sets of So when you test your algorithm, when you are going to look at into environment A and environment B, we see to it that the environments are actually equivalent, if not the same, equivalent or very much similar to each other. And the kind of problem sets that you give to both environments are actually equal, or if not almost the same, equivalent to each other. If the results show that A performs better than B in all the cases, we conclude that A is a better algorithm, provided that all possible controls are actually being considered, and that we always look at that the independent variable produces the effects, or the effect is actually being accounted by the factor or the independent variable that is actually being accounted for. So again, the essence is control of other unwanted external factors. When we look at independent variable and dependent variable, so the effect is dependent, the factor is what we call independent variable. We look at that the independent variable produces the effect, or the effect is actually being accounted by the identified factor or the independent variable. However, we could not actually have that possibility all the time because there are external factors. And those external factors must be controlled by the researcher. And in this book, we classify that one as unwanted external factors. So first, we're going to recap some of the terminologies in research. So variable. So we defined variable earlier as inequality or characteristic in research investigation that has two or more values. So having a characteristic or maybe a quality in a research process in which that term, that word, that statement, that phrase has two or more values. Then I mentioned earlier cause and effect relationship. The extent to which one variable, the cause, influences another variable, the effect. The one that I mentioned, that the independent variable produces the dependent variable. The factor produces the effect, or the effect is accounted by the factor being identified. And then we have independent variable, a variable that the researcher studies as possible cause of something else, the variable that the researcher directly manipulates. Then the dependent variable, a variable that is potentially influenced by the independent variable, a variable that is influenced by and to some extent depends on the independent variable. So we have some basic terms here: variable, cause and effect relationship, independent variable, then dependent variable. So in a diagram we have here, we have the cause, so we have the effect or the outcome. In some books, we classify also effect as outcome. So effect, outcome, or dependent variable. So we have cause, independent variable, or the factor. So in an experimental design, we look at the two, that the independent variable produces the effect, or the effect is accounted by the independent variable. But we could not actually control everything. There might be other factors that produce the effect or the outcome. So there might be other factors that produce the effect or the outcome other than the independent variable. And we call those factors as confounding variables. The other factor is what we call confounding variable. So first, always remember, in an experimental design, we have cause and effect relationship. We see to it that the cause produces the effect, or the effect is being accounted by the cause or the independent variable. But all could not be controlled. there might be cases that the effect is accounted by other variables, other factors, not just the independent variable or the cause. And if it would happen, then we call those things, those factors as other factors or confounding variables. So how do we define confounding variables? So confounding variables account for differences in two or more groups that are not attributable to the particular treatment or intervention being studied. So account for differences in two or more groups that are not attributable to the particular treatment or intervention being studied. So in that diagram, this other factor, this confounding variable, is not actually being determined by the researcher as the possible cause. But this is actually unwanted factor, unwanted events that normally happen during the conduct of the experiment. So there's an example about a coffee shop. A coffee shop was renovated. It was an old coffee shop, so it was renovated. And the purpose of the renovation is to attract more customers. That's the belief of the owner of the coffee shop. To have a new image of the coffee shop and having a new image that would attract more customers. So the location of the coffee shop is actually near to a mall. A mall that is being constructed newly also. So there's a new mall being constructed, and that new mall is just very close to the location of the coffee shop. So after the renovation, there were many customers of the coffee shop. There were many customers of the coffee shop. And at the same time, when the coffee shop was open, the newly mall was also open. So there was a mall newly open, and the opening of the mall and the opening of the renovated coffee shop was at the same time. And there were many customers of the newly renovated coffee shop. So in that case, the owner could not actually account that the increase on the number of customers, the many customers of the coffee shop being accounted through the renovation of the coffee shop. It might be that there are many customers of the coffee shop, which is newly renovated, because of the opening of the new mall. So that's actually what we call part of the confounding variable. That at first the owner expect that there would be many customers during the opening of the renovated coffee shop. Yeah, there was, but it cannot be accounted totally by the renovation of the coffee shop, but it can be accounted to the opening of the newly mall constructed, in which the location of that new mall is actually very close to the location of the coffee shop. So that's the logic behind on cause and effect relationship with reference to confounding variable or other factor. Are you still there? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Then we look at into internal validity. The extent to which its design and the data it yields allow the researcher to draw legitimate conclusions about cause and effect and other relationship. So a new method of teaching science was invented and was deployed on a class for a semester. Also, another teacher continued using the old method in another class. After the end of the semester, a test was taken which shows the students of new method performs better. So with that scenario, can we conclude that the new method is better than the old one? So And we conclude that the new method is better than the old one, wherein a new method of teaching science was invented and was deployed on a class for a semester. Also, another teacher continued using the old method in another class, and after the end of the semester, a test was taken, which shows the students of the new method performs better. Conclude that the new method is better than the old one? So the answer is no. Why? The answer is no. So there might be several factors that can produce this result. And what is the result? That the the students of the new method performs better than those students using the old method. So the answer is no for the question. Can we conclude that the new method is better than the old one? So what are the factors? So we have there the old method and the new method. So the teachers might be different. And one thing that we consider, one is female and the other is male. So that could be actually a factor. And we classify that one as part of the confounding variable. They have different personalities, educational backgrounds, teaching styles, and so on. So that could be another factor that we are going to consider that would affect the result of the experiment. Personalities of the teachers between the old method and the new method, educational backgrounds of the teacher using the old method and the new method, the teaching styles, so forth and so on. So those are some of the variables that could affect the experiment. Even the two groups of students may be different. One might be reading in a higher grade and have more intelligence and motivation. So if you look at the group of students using the new method and using the old method, so there might be differences in terms of the abilities of the students, in terms of the grades of the students, in terms of the IQ of the students, in terms of the motivation of the students. So that could also be some possible factors that can be accounted. There could be several other dissimilarities between the group using the old method and the group using the new method. That's why the answer is actually no. So we look at this. We have 5,000 hours and his vital signs are still strong. Okay? So when you look at this kind of statement, 5,000 hours and his vital signs are still strong. Could you imagine using 5,000 hours? So how many days ang 5,000 hours? One day is equal to 24 hours. So could you divide 5,000 hours by 24? So what is the quotient?
208 days, sir.
208 days. And given that 208 days, his vital signs are still strong. So there is constancy of the vital signs. So that's believable, right? Because it has been repeated for 208 days and then the vital signs of the person are still strong. And that is actually constant from the first day up to 208 days. And that's believable. Why believable? Because that is being done over a period of time, a long period of time. So you have to control confounding variables. The one that I mentioned here, we have bullet number 1, bullet number 2, bullet number 3, bullet number 4 are actually confounding or other factors. So to have a better result of the experiment, we have to control confounding variables. So number 1, keep some things constant. Keep some things constant. So for example, in terms of sex, so we have to have it constant. So old method, male. The new method is also a male. Then we look at also the educational qualification. If male, then master's degree holder. Then the other group, male master's degree holder. And then if the experiment is conducted if the one using the new method is actually in the session, then the one in the old method must be in the morning session, the same period of time. If that is 9 to 10, so 9 to 10 in the new method, 9 to 10 in the old method. So there is what we call constancy in terms of sex, constancy in terms of educational qualification, constancy in terms of the administration of the experiment, 9 to 10 in the morning for both groups. Then both classes are handled by male. Both classes are handled by a male teacher whose educational qualification is master's degree. So things like those. Include a control group. So normally, we have experimental group and then control group. Number 3, random assignment to experimental group and then control group. You're going to randomize who will go to the new method and who will go to the old method. Number 4, assess equivalence before the treatment with one or more pretests. So pretest is normally given before the start of the conduct of the experiment. And the pretest results would tell on whether the two groups have similarity, have equivalence, or maybe equality. Number 5, expose participants to all experimental conditions. So expose participants to all experimental conditions. Whatever experiment is being used in one group, then you are going to have also an assumption that the experimental condition is also applied in the other group. Statistically control for confounding variables. So we have some statistics to be controlled using different variables, different techniques, and through different statistical tools, which will not be discussed in this chapter. This chapter is chapter 9, but that one will be taken in chapter 11. So control group versus experimental group. So control group is a group that receives either no intervention or a neutral intervention that should have little or no effect on the dependent variable. So like in the example given, we have the old method is actually in the control. And then the new method is being used in the experimental group. The researchers then compare the performance of this group to an experimental group, also known as treatment group. So it can be experimental group or treatment group that participates in an intervention. So in terms of diagram, so we have the location of the researcher, then we have here the intervention group, and then we have the control group. So in the control group, the intervention is not actually applied. So in terms of the new method and the old method, so the new method is in the intervention group or experimental group, then the control group is having the old method or the traditional method. And the researcher is looking into the intervention group and then the control group. So categories of experimental designs. So we have true experimental research. So in true experimental research or the true experimental research design, the researcher manipulates the independent variable and examines its effects on another dependent variable. So a variety of research designs have emerged that differ in extent to which the researcher manipulates the independent variable. 5 major categories of experimental designs are. So these are the different experimental designs. So we have pre-experimental designs. So we have the true experimental designs, the quasi or the quasi-experimental designs, the ex post facto designs, then the factorial designs. So let's look at into a pre-experimental design. In pre-experimental design, it is not possible to show cause and effect relationships because the independent variable does not vary, or experimental uncontrolled groups are not comprised of equivalent or randomly selected individuals. So such designs are helpful only for forming tentative hypotheses that should be followed with more controlled studies. So be careful. We have there, such designs are helpful only for forming tentative hypotheses. When you form tentative hypotheses, you can apply pre-experimental design. And after having the pre-experimental design, it has to be followed by more controlled studies. So we have here one-shot experimental case study. So this is a one-shot experimental case study. The one-shot experiment case study is probably the most primitive type of experiment that might conceivably the term research. An experimental treatment is introduced. So this is the diagram. And then measurement or observation, which we call a post-test of some sort, is administered to determine the effects of the treatment. So there's only one group. We call that group as the treatment group. Then the treatment is actually being introduced. Then after the treatment, observations are actually being measured through the so-called post-test. So identify one group, then apply the treatment, then do the observations, and then measure the observations by using post-test. The design has low internal validity because it is impossible to determine whether participants' performance on the post-test is the result of the experimental treatment per se. So once you see the observations as measured in the post-test, so this one is referring to the post-test. The observations are actually referring to the post-test. So these observations could not be totally accounted by the treatment for this certain group. That's why it has a low validity. Next is one group pre-test post-test design. So one group pre-test post-test design. So study group before. So we have before the intervention, then after the intervention. So still the same group, and then you have a before the intervention, and then after the intervention. So in terms of this diagram, you have one group only, then you do a pre-test, then you apply the intervention, then you do a post-test. So here, I repeat, you identify one group, and then you do the observations by doing the pre-test, then apply the treatment, then apply the post-test through different observations. A single group undergoes pre-experimental observation or evaluation. Then is administered the experimental treatment, and finally is observed or evaluated again after the treatment. So we have before the treatment, then this is the treatment period, then after the treatment. The pre-test is before the treatment, the post-test is after the treatment. So example, suppose an elementary school teacher wants to know if simultaneously reading a story and listening to it on audio tape will improve the reading skills of students in his class. So number one, he gives his students standardized reading test. Then has them simultaneously read and listen to simple stories every day for 8 weeks. And then administers an alternate form of the same standardized reading test. So we have pre-test, then post-test. Number two is actually referring to the intervention. We have the simultaneously read and listen to simple stories every day for 8 weeks. So we have the post-test, the pre-test, followed by the intervention. The number three is actually the post-test. If the student's test scores improve over the 8-week period, the teacher might conclude perhaps actually, but perhaps not, that the simultaneous reading and listening intervention was the cause of the improvement. So again, we have 1.1, one-shot experimental case, 1.2, one group pre-test, post-test. Then number 3, 1.3, static group comparison. So what is a static group comparison? So the static group comparison involves both an experimental group and a control group. So this is actually much better than 1.1 and 1.2 because there is experimental group and there is a control group. So an experimental group is exposed to a particular experiment, and then the control group is not. After the treatment, both groups are observed and their performance is being compared. So here's the diagram. So we have group 1 and group 2. Then group 1 has the treatment, group 2 has no treatment. So in this perspective, group 1 is the experimental group, group 2 is the control. And after the treatment, there is what we call observation, and this observation is measured in terms of a post-test. So drawbacks of static group comparison. No attempt is made to obtain equivalent groups or even to examine the groups to determine whether they're similar before the treatment. So if we're going to look at group 1 and group 2, we never know that group 1 and group 2 are equivalent or similar to each other. So we have that speculation that group 1 is better than group 2 or group 2 is better than group 1. So this is one of the drawbacks of using a static group comparison. Thus, we have no way of knowing if the treatment actually caused any observed differences between the groups, the experimental and the control. So if you look at the pre-experimental design, it is actually composed of 3 pre-experimental designs, composed of 3. One-shot experimental case study. We have one group pre-test, post-test design. Then we have the static group comparison. Then we go to true experimental designs. So we have the true experimental designs. Compared to pre-experimental designs, experimental designs offer a great degree of control and greater internal validity. People or other units of study are assigned always randomly. So you know what is random assignment. I mentioned that one in the class. Such random assignment guarantees that any differences between the groups are probably quite small and in any case are due entirely to chance. So this is the diagram on how to have random assignment. So we have the target population in all studies, whether it is experimental design, correlational research design, a survey research design, and all other designs. All of them have target populations. And since the target population is so big, then you are going to have only samples from that target population. So we do the selection randomly. So we select and then the selection is through random assignment. So we randomize who will be in the experimental group and who will be in the control group. And then we have the pretest for 2 groups. So pretest for the experimental and pretest for the control. Then you apply the intervention. So shall we say intervention X? And then this one is the usual one. Then after the conduct of the intervention, you're going to have the post-test. These are observations being called as post-test. There are 2 groups, then intervention, and then post-test. But one thing to be considered in here is that similarity are actually being addressed between control and experimental groups. The second is all about pre-test, post-test control group design. So pre-test, post-test control group design. So in a diagram, so we have random assignment from the target population. We have random assignment. And then the random assignment is done through group 1 and group 2. So the members of group 1 are randomly selected. The members of group 2 are randomly selected. And then there's an observation which we call pre-test. And then after the pre-test, we have the intervention or the treatment. And then in the control group, there's none. That's the old method. Then we look at the observation or the post-test. We have to consider a certain time. When are we going to have the post-test? We have the pre-test, then the intervention, and then the post-test. And what's the time between the pre-test and the post-test? What's the interval? What's the duration? So it would depend on the review of related literature. As I mentioned, every time you do a certain design, you have to read related literature. This design, simple as it is, solves two major problems associated with pre-experimental designs. We can determine whether a change takes place after the treatment, and if so, we can. Then number 2, eliminate most other possible explanations in the form of confounding variables as to why the changes has taken place. The confounding variables are being addressed through random assignment. Remember, one of the things to control confounding variables is through randomization or random assignment to both groups, experimental group and control group. Next, we have Solomon for group design. So the Solomon for group design. This is a variant of the previous design. So just like COVID, we have also variant. So we have variant also in terms of research design. No? A variant of the previous design, which is independent of any bias during the pre-test phase. So this is the diagram for Solomon for group design. So from the term itself, there are 4 groups. So we have group 1, group 2, group 3, and group 4. And of course, there is random assignment. So from the target population, there is random assignment. Random assignment on who will go to group 1. Random assignment who will go to group 2. Random assignment on who will go to group 3. Random assignment on who will go to group 4. And we have here observations. So pre-test for group 1, pre-test for group 2. But group 3 and group 4 has no pre-test. And then the treatment is in terms of interval. So group 1 has a treatment, group 2 control, then group 3 there is a treatment, and then group 4 has no treatment. So if you look at the 4 groups, group 1 and group 3 are treatment groups or experimental groups. Group 2 and group 4 are what we call the control groups. Unlike in the previous one, where there is only one experimental group and there is only one control group. But under Solomon, for group design, there are 2 experimental groups and there are 2 control groups. Then, at the end, we're going to compare group 1 and group 2. Then we're going to compare also group 3 and group 4. The comparison is through statistical methods. So the comparison is through statistical methods. 2.3. So post-test only control group. So post-test only control group design. So some life situations defy pre-testing. So pre-testing is not possible. So in some cases, we can do pre-test and we can do post-test. But in some cases, pre-testing is not possible. So example, pre-test the forces in a thunderstorm or a hurricane. Also, sometimes it might be difficult to locate a suitable pretest, or the very act of pretesting can influence the results of the experimental manipulation, because the pretest and the post-test are similar. So having a pretest would also have an impact on the post-test, because the post-test actually is very much similar to the pretest. In such circumstances, the post-test only control group design offers a possible solution. So random assignment to groups is, of course, critical in post-test only design. So still, we have the target population, then we have the random assignment. So random assignment for group 1, then random assignment for group 2. So people who will be going to group 1 are randomly assigned. People who will be going to group 2 are randomly assigned. And then again, group 1 treatment or the experimental, group 2 is the control. And after the treatment, there is an observation, and the observation is in terms of post-test. So you notice in this case, there is no pre-test between group 1 and group 2, or between experimental and control group. Number 3 is the quasi-experimental designs, or the quasi-experimental designs. Are you still there? Hello?
Yes, sir.
Yes,
Sir.
Yes, sir.
Is my audio
Yes, sir.
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
okay? So we go to quasi or quasi-experimental designs. No? The quasi-experimental design is a type of experimental design in which the researcher has limited leverage and control over the selection of study participants. So, specifically in a quasi-experiments, the researcher does not have the ability to randomly assign the participants and or ensure that the sample selected is a homogeneous as desirable. So random selection is not possible or not practical. Next, accordingly, the ability to fully control all the study variables and to the implication of the treatment on the study groups may be limited. Nevertheless, quasi or quasi-experiments still provide fruitful information for the advancement of research. And when we look at the quasi or the quasi-experimental science, we have intact groups as our target population. Intact groups as our target population. Unlike in a true experimental research science, that our target population is composed of individuals or individual persons. There's a microphone not being turned off, so kindly turn off your microphone before I remove you. There's a microphone not being...
Wait lang, napaka-utang na ako dyan, Ray. 59.
whose microphone is that? So turn it off before I remove you from the panel. So this is the diagram. So target population. Our target population is actually intact groups, not in terms of individuals, like sections or maybe a certain group. So the total target population is by group or by clusters. Then we have the selection, the pre-test, and then the pre-test for both experimental and control. And again in here, although it is not mentioned that it is randomly assigned, so you have to randomly assign who will go to treatment and who will go to experimental. But there are actually some designs using the quasi in which the researcher does not randomize. Automatically, the researcher decides who will go to intervention and who will go to the control group. So this is actually very much similar to the true experimental design. There are two groups, experimental group and control group. There's intervention for the experimental, no intervention or using the old one, the traditional for the control. And then post-test is given to both experimental and control groups. So in here, randomization is not possible. However, there is a possibility of randomizing and that the target population is actually in terms of clusters or in terms of sections or in terms of groups. Unlike in a true experimental design, that the target population is composed of individuals. We count the number of students, we count the number of plants, we count the number of objects. In a quasi-experimental design, we count the number of sections. Like in the example that I have given, if you go to Negros Oriental High School, there are 15 sections of grade 7. Your target population is referring to all grade 7 students of Negros Oriental High School. Then our target population is composed of 15. And that 15 is not in terms of individual students, but 15 in terms of sections or in terms of intact groups or clusters. So an example of a quasi-experiment that does not provide random grouping of participants may be an investigation of the impact of IT use policy training on employees' IT misuse in an organization. It may be very well be that the researcher has no control over which group of employees will receive the training and which group will not, as these are based on departments. So department, the entire company is by department. We group that one by department or intact groups. However, prior research may have indications that employees' computer experience and age have direct implication on employees' IT misuse in an organization. Furthermore, it is very likely that the researcher has a very little control over the distribution of the moderator variable. Yes. Employees' age and computer experience in this example is a moderator variable. We know already in terms of information technology, one of the factors that the implementation is on age. Young ones are actually good in IT, but the old ones are not that good. So that could also be a moderating variable. While being able to measure IT misuse before the training and after the training, comparing experimental and control groups. Even if participants were not randomly distributed, may provide some good indications about the implications of the training, given that the employee's computer experience and age were measured and showed no significant main differences between the two groups. When we look up into no significant main differences, this will be discussed in the next chapter that we're going to take up about the statistical process in the analysis of data being collected from different research disciplines. So 3.1, non-randomized control group pre-test, post-test design. So we have group 1 and then group 2, non-randomized. So people who go to group 1 is not randomized. People who go to group 2 is not randomized. And still, there is what we call observation before the treatment, observation after the treatment. In the control group, group 2, there's no treatment. This is actually using the traditional one. But still, there is pre-test and there is post-test. Remember, the observations, the OBS is referring to observations. And this would actually refer to the pre-test and then the intervention and then the post-test. To show that two groups are equivalent with respect to the dependent variable prior to the treatment, thus eliminating initial group differences as an explanation for post-treatment differences. So, key difference with the experimental design that the test and control groups are not totally equivalent due to lack of randomness. So, in here, we could not say that group 1 and group 2 have equivalence. Group 1 and group 2 have equality or similarity because at the beginning, there is no randomization on who will go to group 1 and who will go to group 2. 3.2, sample time series experiment. So we have also time series experiment. A time series experiment design consists of making a series of observations, introducing an intervention or other new dynamic into the system, and then making additional observations. If substantial change is observed in the second series of observation compared to the first series, we might reasonably conclude that the cause of the change was the factor introduced into the system. So the diagram looks like this. Group 1, there's only one group. So we have observation, 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 observation. These different observations are actually having different intervals. And the interval is based on the review of related literature. How do we know the interval? From the first observation to the second observation, then from the second to the third, from the third to the fourth observation. We call that one as the time or the interval. So only the review of related literature will tell what's the ideal interval between and among observations. Then after that, we have the treatment, and then observation, then another period of observation, then another period of observation, then another period of observation. That's why we call this one as the time series experiment. So you conduct there 4 observations, treatment, then conduct also 4 different observations after the treatment. The number of observations before the treatment must be the same to the number of observations after the treatment. And it does not mean 4 only. You can have 5 observations before the treatment and then 5 observations. 3.3, control group time series design. So this is a variation of the previous design in 3.2 with introduction of control group. So in here, there is no control group, only the treatment group. Under control group time series design, so we have group 1 and group 2. So group 1, the intervention or the experimental group. Group 2, the control group. And then we have 4 observations before the treatment. And then we have also 4 observations in the traditional method. And then 4 observations. But it does not mean we only have 4 observations. It would depend on the review of related literature. You might have 3 observations only before the treatment and 3 observations after the treatment. Or you can have 5 observations before the treatment and 5 observations after the treatment. Then do that one also in the control group. 4 is the ex post facto designs. In many situations, it is either unethical or impossible to manipulate certain variables in order to investigate their potential influence on other variables. So, for example, a researcher cannot intentionally infect people with a potentially deadly new virus will hold instruction as parents to abuse their children. So, meaning the event had happened already. For example, you want to identify the effects of smoking. You are going to have that kind of design wherein you are going to identify the effects of smoking. Although we have that in the literature, but you want to study that one again based on ex post facto design. You could never conduct an experiment that the experimental group, you're going to let them smoke, and then in the control, the people there do not smoke. And then find out the effects after smoking and those who don't smoke. We could not do that because we know for a fact that smoking has some effects. So that's very unethical. So we could not actually do the other kind of experimental designs. That's why we look at into ex post facto designs. The ex post facto designs are actually used to determine the effects, to determine the outcomes after the event had happened, after the phenomenon had happened already. In ex post facto design, the researcher identifies events that have already occurred or conditions that are already present and then collects data to investigate a possible relationship between these factors and subsequent characteristics or behaviors. So like correlational research, ex post facto research involves looking at existing circumstances. Like experimental research, ex post facto research has clearly identifiable independent and dependent variable. Unlike experimental research, ex post facto research involves no direct manipulation of the independent variable. The presumed cause has already occurred. So the cause has already occurred. So maybe the cancer, lung cancer, and then you can account that one with smoking. So smoking had occurred already, had happened already. And we could not actually conduct an experiment na let people smoke and then find out the event, the effects. Or let people take drugs and find out the effects. So we could not do that. But we can do that by identifying who are smokers and find out the effects, who are drug addicts and find out the effects. So those are some common things that we consider about ex post facto research. So simple ex post facto design. So simple ex post facto design is similar to static group comparison. So important difference with the static group comparison is one of timing. In this case, the treatment in question occurred long before the study began. Hence, we call it an experience rather than a treatment because the researcher has not been responsible for imposing it. So we look at the diagram. So group 1 and group 2. So we have group 1 prior events, meaning if we look at the example that I have given on the effects of smoking, so the prior event would be group 1 is composed of people who smoke already and has been smoking up to the present on the conduct of the ex post facto research design. Group 2 are those non-smokers up to the present time of conducting the ex post facto research design. After that, you do the investigation, you do some observations, you do post-test assessment. So in here, we have the example smokers, the one that I mentioned. So the one that should be in group 1 are those smokers and even smoking up to the time of the conduct of the ex post facto design. Group 2 are the non-smokers up to the present the time of conducting the study. And then investigation period. So you're going to investigate, you're going to find out factors, you're going to apply the post-test. Next one is factorial design. So examination of the effects of 2 or more independent variables in a single study. And then randomized 2-factor experimental design. So there is randomization in here. From the target population, you are going to have random assignment. Randomize who will go to group 1, randomize who will go to group 2, randomize who will go to group 3, randomize who will go to group. And then treatments related to the 2 variables may occur simultaneously or sequentially or by order. So treatment related to variable 1. So treatment 1 for both group 1 and group 2. And then we have here group 3 and group 4. So group 1, we have treatment 1, treatment 2. Group 2, treatment 1 without treatment 2. And then group 3, no treatment 1 but with treatment 2. Group 4, without treatment but with treatment, without treatment also. So if you look at group 4, no treatment for variable 1, no treatment for variable 2, but observation is given. So we have the post-test. We have post-test also for group 3. No treatment for variable 1. There is treatment for variable 2 and then the observation or the post-test. Group 2, there is a treatment for variable 1, no treatment for variable 2, and then there is post-test or observations after the conduct of the experiment. Group 1, we have treatment 1 for both variable 1, and then treatment 2 for variable 2, and then observations or the post-test follow. Again, the time is actually a factor. So the time interval is actually a factor. We could not specify on what is the exact interval, but that would depend on your review of related literature. What is the interval between treatment 1 and treatment 2? So if you look at into factorial designs, there are actually many examples in the internet. So that would be the last topic that I am discussing in this chapter. And I'm going to give assignment. No? We have 1, 2, 3, 4, 5 different designs. So I mentioned that one here. So we have these are the things that I mentioned. Hold on. Going to locate that in my slide. Okay, this one. So these are the 5 research designs. Now, pre-experimental, true experimental, the quasi or the quasi, then the ex post facto designs, and the factorial designs. So your assignment for this chapter, 1 research article per design. 1 research article for pre-experimental, 1 research article for true experimental, 1 research article for quasi-experimental design, 1 research article for ex post facto, 1 research article for factorial design. But do not recycle the research article that you have submitted last time. So find another research article. You have already an idea based on my discussion on what are these different designs and based on this chapter. So I'd like you to choose another research article. When I say a research article, that would mean there's a title, there's an author or authors, then there is an abstract, keywords, introduction, then the other parts of the research article up to the references section. So print each of those research articles. You will have 5 different research articles. Print all of them. And at the back of the last page, you're going to indicate how the researcher used the research design. If there is a pre-experimental design, then how the researcher use the pre-experimental designs. How the researcher use the true experimental design. And then, if you're going to look up into the chapter, like pre-experimental, there are many designs. The true experimental designs, there are many. Then the quasi, the ex post facto. So I'd like you to have only one out of the many classifications. So number 1 has many sub-designs. Number 2 has many sub-designs. Number 3 has so many sub-designs. So with number 4 and the factorial design. But just have one for each. So is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Any clarification? Any clarification?
Is staple Ramos, sir, or a folder?
The same, just staple the papers. And then the same to what you did last time. No? Do not have that one in a folder. So you will have 5 different research articles. And then for each research article, just staple that one. If that is very thick and the staple wire does not have the ability to clip that one, then just make use of a fastener. But still in different perspective. So you will have 5 different stapled papers or 5 different fastened papers using fastener. Is that clear to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
So when we get back on January, it's a silent week, but we're going to have a discussion of your assignment, the Q&A of your assignment, graded recitation of your assignment. So still classes will go on. And on the second week of January, it's the final week, but we're not going to have our finals. We are going to have still classes. We're going to have the finals after the schedule of the final week. Okay. So any clarification? I'm going to send the video, the recorded video of our discussion tonight, this evening, for review purposes. So I'll stop sharing and then Mr. Bininoso, any clarification? Genre, clarification. Romil, clarification. Stephanie, Regine,
None, sir.
Abelianeda, Joshua, Josephine, Byron, Miss Duran, James Lasola, Liza, Jenalie Duran, Sheer Alcantara,
None, sir.
Sir, present ko, sir.
Mr. Ibero, Mr. Montesino, I guess you are lying on your bed.
Yes, sir. Pero naminaw, sir.
Again. So it's not good to lie on your bed without someone beside.
Eh.
Oh yeah, Byron Fernandez, clarification?
Sir, I would like to ask, sir, um, can we ask for I mean, are you going to post your instruction sa Google Classroom, sir? Because I'm having hard time jotting down notes about your instruction because I don't have a strong internet connection.
Dili na. But just this one, as someone whom you know, no? Number one is you are going to have a research article for each of the 5 designs. There are 5 designs in the chapter. So one research article from pre-experimental to factorial design. Pre-experimental has many designs, but just choose one there. Number 2 has many sub-designs, but choose one only out of the many. Number 3 has many sub-designs, then choose only one. So if you're going to look at that one in the internet, there are many designs. As long as it is pre-experimental, then up to the factorial design, so that's okay. Basta you have all the 5 from pre-experimental to factorial design. And I don't care on what kind of sub-design. For example, pre-experimental has many sub-designs. So just choose any one of those design under pre-experimental. Even in a true experimental design, there is what we call Solomon 4-group design, but it does not mean that you are going to have each of those sub-designs, but have only one under the true experimental design. I'm sorry, Mr. Quano, Mr. Bininoso, because I seldom, when I have already the video. Anyway, you can actually review the recorded video. I'm going to post this one into the stream for specific or just a review of what we have taken this evening. Is that clear to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
For attending
Yes,
this
sir.
special meeting, no? Thank you so much for attending this special meeting. I know you are in your respective houses for Christmas vacation. I'm also in my house in Aldea Home, Sibulan. Not for a Christmas break, no, because we don't have, we are still reporting to the university up to Friday. The next week, we will be reporting also because I'm a faculty with an admin designation, so we don't have vacation. And then, uh, I'm saying thank you very much for attending this special meeting. I know nga this one is a disturbance of your vacation, but thank you very much, no, for this. So,
Thank you, sir, for the
Texas
PPT.
Oriental State University, Main Campus 1 College of Teacher Education. Merry Christmas, everyone, and advance Happy New Year. See you next year, no?
Thank you, sir. Thank you, sir.
Thank you,
Sir, Merry
sir.
Christmas. Advance Happy New Year po.
Thank you, sir.
Merry Christmas
Bye,
po,
Do
sir.
not
guys.
eat much to count the number of calories that you are
Happy holidays, sir.
taking on the Noche Buena para dili kayo mo tambok, no? When we get back on January. Okay, so if there are no clarifications, then I'll be taking another screenshots para those who were not able to catch the attendance checking, I can just go over the screenshots, no? So open your camera, show your best smile. The best smile will have another extra credit. Show your best smile. Okay. Show your best smile. Mr. Maloney, asa man si Mr. Fausto? Smile.
Wala. Kabalo, sir. Nada win,
Ah,
sir.
naraspet panday. Hey. Smile, smile. Trishi, I saw you at Pitong Gatang. Do you live there? Nakamute ka, Trishi. I saw you at Pitong Gatang at the corner. So I assume nga you live somewhere there. Okay, bye-bye.
Yes, sir.
everyone.
I live in Pitong-Gata.
Good evening, everyone. Again, Merry Christmas and advance Happy New Year.
Sir.
Sir, good evening.
Phil Balagan, I like your
Bye-bye. Thank you, sir. See you next year.
I am alone. Don't forget your diet. Miss Magpapa, get your diet.
Pasko niya, sir.